So we're going to take some more examples about practicing about the chain rule properties. So when we have, let's say, differentiation of something like sine cube x or a more complicated functions like these. So in such cases, what we basically do is just wanted to remind about the properties that we had done. So in case of, let's say, some function to the power n, if I have some function to the power n, the derivative of that expression is n times function to the power n minus 1 times f dash x. So that's the property that is that I applied here. So if I have, let's say, sine x the whole cube function, sine cube x can be first rewritten like this. So what I'm going to do is, this is my function here. Now, if you compare my f of x is sine x, so it's going to be 3 times sine x to the power 2 into the derivative of sine x, which is nothing but cos x. So that's how you do the derivative of sine cube x function using the chain rule that we learned. Now, second example is, let's say if I have square root function, how do we do this? So if I have something like square root of a function, I'm going to just do firstly half fx to the power of negative half into f dash x. So because it's like x to the power half, I can write down this as, so it'll be half x to the power negative half. So that's the derivative. So I'm using this straight away. So in such cases here, what is going to happen is you're going to just rewrite this as half. So I can rewrite this as x squared minus 10x plus 5 to the power half. And then you write down the derivative. So it's like half x squared minus 10x plus 5 to the power negative half, because half minus 1 is negative half, times the derivative of x squared minus 10x plus 5, which is 2x minus 10. So this is the derivative function for this given expression, and which can be further simplified out here. So 2x minus 10 I can retain in the numerator, this 2 as it is, and this I can bring down in denominator like this, which further simplifies if you take 2 common from numerator and cancel out this with 2. So you get this is my final expression. So these are the 2 examples about the power chain rule. Well, let's just take some more example about the more complicated questions. I'm just going to straight away show you the solution and just probably go over with you. So we just did about the derivative of sine cube x and cos cube x, I mean sine cube x function of. So that same logic is here. So I'm going to first take sine cube and cos cube, rewrite this like here. And then the derivative of sine cube x is 3 times sine x the whole square times cos x. And the derivative of cos cube x is 3 times cos x the whole square times minus sine x. So because it is cos, it's fx to the power 3. So it'll be 3 times fx square times derivative of cos x, which is minus sine x. And of course, you can take further something common. Now, going to the next example, if I have to differentiate root ln x plus root cos x, I can take it as ln x to the power half plus cos x to the power half. And then you differentiate half fx to the power half minus 1, which is this, times derivative of ln x, which is 1 over x. Now, derivative of root cos x is half cos x to the power minus half times the derivative of cos x, which is negative sine x. So this is how you do the power chain rules. I hope there are more than enough examples on power chain rule. We can take one more, the last one, which is e to the power x plus 4x squared plus 7 to the power 5. If you want to try on your own, you can try this. But just here, if it is, once again, it is fx to the power 5 kind of example. So the differentiation for this is going to be 5 fx to the power 4 times the derivative inside, which is e to the power x plus 8x. So that's how you do the derivative of the power chain rule. Now, coming to the practice on the next type of questions, which is like the sine, cos, and ln and all. Here are some more examples that we can go through. So as we know, sine fx is cos of x times f dash x. So if we have, let's say, sine of x cubed minus 3x plus 7, it's going to be cos of fx. So cos fx we can see times f dash x, which is the derivative of this. So that's how you basically get the chain rule. Now, cos fx we know is negative sine fx times f dash x. So if I have something like cos of ln x, it is going to be minus sine of ln x times 1 over x, which is nothing but the derivative of ln x. Now, the derivative of ln chain rule. Now, if I have ln fx, it is 1 upon fx times f dash x. So if we have, let's say, ln x squared minus 4x plus 3, the derivative of that is going to be 1 upon fx. So that's 1 upon this whole thing times the derivative of fx, which is 2x minus 4. And the last fragment is the exponential function differentiation. So if I have e to the power x derivative, it is going to be e to the power fx times f dash x. So a bit of practice on that. If I have e to the power sine x, so as it is, e to the power fx is e to the power fx in first step times derivative of sine x, which is cos x. So this is how you do the chain rule, and we'll create some more practice segments on chain rule later on.